imagine for a second that you're gathering the world's brightest engineers, right? And they're building this revolutionary, hyper-efficient engine. You'd probably expect everyone to be cheering.
Oh, absolutely.
Yeah, but instead, as these engineers are, fine-tuning the pistons, half the spectators are actively lobbying to strip the gears out before the engine even starts.
Which is just wild to think about.
It really is, and that is exactly what the data inside the annual Stanford AI Index reveals about the current state of artificial intelligence. Welcome to today's deep dive, by the way. I am so glad you're joining us. Our mission today is to unpack this really fascinating digest piece, drawing from a technology review article on that Stanford Index.
Right.
Because we need to understand exactly why public opinion on AI has become so intensely polarized.
Right.
We're looking at a field where the tech trajectory is moving at breakneck speed, but public opinion has just, well, it's entirely fractured.
It's a fascinating paradox, really. I mean, the developers, they're building what they believe is basically a utopia engine, while a massive portion of the public views that exact same machine as a bulldozer headed straight for their living room.
That's a great way to put it.
And the source text has this great analogy. The Stanford AI Index functions as a kind of telemetry check, like a pit stop in this incredibly fast-paced marathon of AI development.
Try a pit stop. I like that.
Yeah, it pauses the race, pulls the data, and shows us exactly where the rubber is meeting the road. And here's where it gets really interesting. What the telemetry shows this year isn't a unified march toward the future at all.
Right.
It's two fundamentally incompatible realities just trying to occupy the exact same space.
Okay, let's unpack this. Because to understand why this engine is causing so much friction, we sort of have to get inside the heads of the people actually building it, right?
Exactly.
The tech enthusiasts, the industry insiders, the developers living right up the center of the tech bubble. Because from their vantage point, I mean, this isn't just an iterative software update. It is a fundamental rewiring of human capability.
It really is.
Yeah.
And we have to understand why they feel that way mechanically. Because it's not just, blind Silicon Valley hype.
Right. It's based on something real.
Right. Their optimism is forged in the feedback loop of their daily reality. So think about a developer working with advanced large language models. They are experiencing this raw, compounding productivity every single day.
Give me an example of what that actually looks like for them.
Well, say they write a piece of code. The AI optimizes it in milliseconds, which then allows them to build a better tool, which then optimizes the next process even faster.
Oh, wow. So it just builds on itself.
Exactly. When your day-to-day experience is watching a system successfully debug complex architecture or fold proteins in an afternoon.
Stuff that used to take human teams months.
Months or even years.
Yeah.
When you see that, your baseline reality shifts. You start viewing the technology as an infinitely scalable solution to virtually any friction point.
Okay. I mean, I understand the logic of that feedback loop,
Yep.
but I want to push back on how scalable that perspective actually is outside of a coding environment.
Sure.
Because think about it mechanically. It is incredibly easy to think a pneumatic nail gun is the greatest invention in human history when you are the carpenter getting paid to build the house.
Oh, yeah, absolutely.
You pull the trigger, the house goes up in half the time, and your profit margins skyrocket. But what if you aren't the carpenter? What if you're the neighbor dealing with the shattered windows because the foundation was rushed?
That's the real question.
Right. So does operating entirely within that localized feedback loop create a dangerous blind spot for the developers?
What's fascinating here is that analogy is super useful, but the text reminds us we have to be careful not to frame the developers as actively malicious or, intentionally ignorant.
Fair point.
It's less about a deliberate blind spot and more about just the nature of localized optimization. The Stanford telemetry data shows that expectations are entirely dictated by proximity.
Proximity to the tech.
Exactly. When you are the carpenter, you are looking at the micro efficiencies, the perfectly driven nail.
Yeah.
You aren't looking at the macro vibrations shaking the neighborhood.
Right.
The insiders are experiencing real-time, measurable wins in processing power and task completion. And that creates an insulated reality where the tech's benefits are totally quantifiable, while the societal frictions it causes seem, abstract.
Or solvable with, ironically, just a bit more technology.
Exactly.
Okay, so the inside of the bubble is defined by these quantifiable micro wins. But let's step outside the blast radius of that localized optimization.
Let's go.
Because that proximity effect works in reverse, too. If you are standing outside the bubble, you aren't experiencing the micro wins. You're just feeling the macro vibrations. And
Yeah.
what the data shows is a profound, incredibly rational anxiety.
It really does. And it's crucial to break down the mechanics of that anxiety for everyone listening, because it isn't just, science fiction paranoia about rogue robots taking over.
No, it's very real.
The index points to tangible socioeconomic disruptions. And the first layer here is the evolution of job displacement.
And we aren't talking about automated assembly lines anymore, are we?
No, we are talking about the sudden devaluation of cognitive labor. Think about it. When an AI can instantly synthesize a 50-page legal brief or generate a comprehensive market analysis, the anxiety from the mid-level analyst isn't just, I might lose my job.
It's deeper than that.
It's the realization that the specific cognitive skills they spent a decade mastering suddenly have a market value approaching zero.
Wow. Yeah, it's a complete structural shift in what society considers valuable labor. But the displacement is just one piece of the puzzle.
Yeah.
Right? The friction really compounds when we look at how these models make decisions.
Oh, the decision-making process is huge.
Specifically regarding bias, and I want to get into the actual mechanics of this, because I think bias gets thrown around as a buzzword a lot. It's not like developers are sitting in a dark room maliciously writing prejudiced code.
Precisely. It is literally a mathematical inevitability based on training environments. Modern AI models learn through what are called vector embeddings.
Vector embeddings. Okay, walk us through that.
So they map words and concepts as numerical coordinates in a massive, multi-dimensional space. And this is based on billions of pages of human-generated internet text.
Just vacuuming up everything we've ever written.
Everything. So if, historically, the word doctor appears mathematically closer to the word man across 50 years of digital archives, the AI plots those coordinates closer together.
I see. It is holding up a statistical mirror to human history.
Exactly. The problem is that when a bank or a hiring firm uses that model to filter applications, that historical statistical artifact dictates a real-world outcome for an individual today.
Which brings us to the most critical driver of this public anxiety, the opacity of those decisions, the dreaded black box.
Yes, the black box.
Because if a human hiring manager denies you a job, you can theoretically ask them why. You can interrogate their logic. But with these models, that interrogation process completely falls apart.
It disintegrates entirely. And this is where the divide between the insiders and the outsiders becomes a total chasm. The public naturally assumes AI operates on human-readable logic, like a complex Excel spreadsheet with clear if-then rules.
Right. If X happens, do Y.
Exactly. But deep learning neural networks do not work that way at all. They consist of billions, sometimes trillions, of parameters spread across hidden computational layers. The model finds hyperdimensional, nonlinear patterns that a human brain literally cannot visualize.
It's just too much math.
Too much math. When a system flags a transaction as fraudulent or denies a mortgage, there is no single line of code responsible for that decision. It is the culmination of microscopic weight adjustments across the entire network.
Okay, I like to think of it like a master chef who has suffered a bizarre form of amnesia.
Oh, I'd like
But like they can go into the kitchen, use 1,000 ingredients, and bake the most mathematically perfect cake you've ever tasted. But when you ask them to write down the recipe, they just stare at you.
They literally don't know.
They physically cannot explain the steps they took to get the result. The outcome is impressive, sure, but if you have a severe peanut allergy, are you going to eat that cake?
Definitely not, no.
Because the inability to explain the process creates an absolute fundamental lack of trust.
That is exactly the mechanism driving the public mistrust. And the Stanford data validates this perfectly. If your economic fate, your loan approval, your resume screening, your medical diagnosis is being handed over to an amnesiac chef, suspicion isn't just warranted, it's a required survival instinct.
Wow.
The outsider experiences profound vulnerability because they are subjected to an infrastructure they cannot audit, created by people they do not know.
So what does this all mean? We have established the two realities. We have the developers sprinting on the treadmill of compounding productivity, and we have a public feeling entirely alienated by an unauditable, shifting economic landscape. The really fascinating question is, what happens when these two immovable forces collide in the real world? Because this isn't just a philosophical debate happening on internet forums anymore. This collision is dictating how billions of dollars are moving.
It's driving immense volatility. If we connect this to the bigger picture, let's look at how this plays out causally, starting with financial capital.
Okay, follow the money.
Right. When you have a fractured public perception, investment behavior becomes chaotic. You see massive pools of capital being deployed entirely based on insider hype. throwing billions at foundational models purely for the sake of scaling compute power.
Just going as fast as possible.
But simultaneously, because of the massive public anxiety, you see a reactionary pivot. Entire portfolios are shifting away from pushing boundaries and moving heavily into defensive AI.
Defensive AI, what does that look like?
Startups whose entire value proposition is just compliance, auditing, and building guardrails.
Oh, I see. It's like half the investors are paying to build a faster race car, and the other half are exclusively investing in airbags and crash test dummies because they are convinced the car is going to hit a wall.
That is the perfect analogy. And that capital allocation directly dictates the direction of the research. If the market is terrified, researchers have to divert massive amounts of time and processing power away from core capabilities and into what the industry calls alignment.
Right.
Basically trying to force these massive opaque models to behave predictably. But the most disruptive fallout from this collision is actually in policymaking.
Because the policymakers are essentially trying to steer a massive ship or referee a game where they don't even fully understand the physics of the ball.
Precisely. The lawmakers are caught between the aggressive lobbying of the insiders who claim regulation will kill the economy and the loud, completely valid demands of a public terrified of algorithmic overreach.
So what do?
Well, because lawmakers cannot easily regulate the black box. I mean, they can't write a law dictating how a multidimensional vector space should behave. They swing wildly. We see this massive pendulum effect.
Explain that mechanism. What does that pendulum swing actually look like in practice?
On one extreme, you get total, dangerous deregulation, the let-it-run approach.
Oh, boy.
Right, where lawmakers back off entirely, allowing a few massive tech monopolies to release largely untested, opaque models into the wild, treating society as a live beta test.
Which just exacerbates the public's feeling of vulnerability.
Right. But then on the other extreme, you get knee-jerk over-regulation. Because regulators can't audit the algorithm itself, they try to regulate the hardware.
Like the physical computers.
Exactly. They propose arbitrary thresholds on computational power, or FLOPs, essentially saying you can't use more than X amount of supercomputers to train a model without government approval.
Does that actually work?
Not really. This kind of clumsy regulation ends up crushing open-source developers and small researchers who are actually trying to build transparent models.
Yeah.
While doing very little to stop the massive corporations who already have the resources to bypass the red tape.
So the extreme regulation actually reinforces the monopolies. It's a vicious cycle. The public fear drives clumsy policy. The clumsy policy entrenches the tech giants. The tech giants build more opaque models, which generates more public fear.
Exactly.
We are caught in a feedback loop of structural instability.
That is the exact systemic risk the index points to.
Yeah.
A fractured public consensus doesn't just mean people are arguing on social media. It means the entire developmental pipeline funding, research, and governance becomes entirely erratic.
Which means we desperately need a circuit breaker. We cannot afford to have the infrastructure of the next century built on top of a volatile, oscillating fault line.
No, we really can't.
So the telemetry data lays out the problem beautifully, but how do we actually bridge this chasm? How do we build a unified framework when the two sides are speaking entirely different languages?
The source outlines some concrete solutions. Bridging the divide requires fostering open dialogue among all stakeholders, right? And the required framework rests on three heavily interconnected pillars.
Okay, what are they?
Radical transparency, widespread structural education, and a rigid operationalized commitment to ethical AI development.
Okay, big concepts.
Big concepts. But we have to look at what those terms actually mean practically, not just as like corporate PR buzzwords.
Let's start with transparency, because that seems to be the linchpin. If the core problem is the amnesiac chef, the black box, how do you mandate transparency on a mathematical system that is inherently unreadable to humans?
It's tough, but you have to mandate transparency at the perimeter of the box, even if you can't perfectly eliminate the inside.
Okay, the perimeter, what does that mean?
In practice, this means institutionalizing things like comprehensive model cards. Before a model is deployed, developers must publicly detail the exact data sets it was trained on, its known failure rates, the specific hardware used, and the mathematical boundaries of its intended use cases.
Oh, so laying all the cards on the table.
Exactly. Furthermore, it requires massive, incentivized funding into mechanistic interpretability.
Mechanistic interpretability. Okay, break that down for us.
It is an entire subfield of AI research dedicated solely to reverse engineering the black box.
Really?
Yeah. It's the science of trying to map human understandable concepts onto those billions of hidden weight adjustments. If we can't write a law to govern the model, We have to fund the science that decodes the model. Transparency isn't just about PR disclosures, it's a literal engineering hurdle that has to be solved.
And I imagine that directly feeds into the second pillar, education. But again, we are talking about a deeply technical subject. You can't expect the general public to get a PhD in neural network architecture just to apply for a mortgage.
No, you don't need them to understand the math, but you do need widespread structural education on the capabilities and limitations of the system.
Meaning what exactly?
The public needs to be educated out of the science fiction mindset. They need to understand that an LLM is essentially a massive prediction engine guessing the next most mathematically probable word, not a sentient oracle.
Right, it's a tool, not a magic 8-ball.
Exactly. When the public understands what the tool actually is, they can better identify when it is being misused by institutions. It shifts the burden of accountability from the invisible algorithm back onto the human institution deploying it.
Okay, so if I understand this correctly, I can see how these pillars intersect. If you mandate transparency on the training data and you educate the public on how to demand accountability, you naturally force the third pillar, ethical development.
do.
And I want to be clear here for everyone listening. In this context, ethical doesn't mean some abstract moral philosophy, does it? It's an engineering requirement.
That is exactly the point the source drives home. It is about system stability. Think about a bridge. A bridge isn't ethical because it has nice lighting. It's ethical because the engineers accounted for the wind shear and the weight limits so it doesn't collapse under pressure.
Wow, yes.
Ethical AI development means treating socioeconomic impact as a core engineering metric, not an afterthought. It means you don't release a model for corporate HR departments until you have mathematically proven, through exhaustive stress testing, that its vector embeddings do not discriminate against vulnerable communities.
You treat bias and displacement the exact same way an aerospace engineer treats metal fatigue.
Right.
It is a fatal flaw in the system that must be engineered out before launch.
Precisely. And this is why bridging the gap is so difficult. It requires the insiders to step out of their hyper-optimized coding environments and accept that real-world friction is their engineering responsibility.
And what about the outsiders?
It requires the outsiders to actually engage with the mechanics of the technology, rather than just reacting to the fear of it.
It really sounds like a massive societal team effort. And honestly, as I look at this entire landscape, connecting the dots here brings up a really difficult paradox.
What's that?
Well, we are sitting at this pit stop looking at the telemetry. We know we need radical transparency to build trust. We know we need a mechanistic interpretability to open the black box. But the foundational reality of AI research right now is that capability scales inversely with interpretability.
That's the painful truth.
The larger and more powerful these models get, the fundamentally harder they are to understand, even for the people building them. So we are in a technological stalemate. We are demanding transparency from a system that is evolving by design to be less transparent.
That is the exact friction point that defines this era of technology. We are trying to build regulatory and social frameworks for an engine that is literally rewriting its own blueprints while it's running.
So let's take a look at the ground we've covered today. We pulled the telemetry from the Stanford AI Index and saw a world aggressively split in two. We looked at the mechanics of the insider bubble, that intoxicating feedback loop of compounding productivity and localized optimization.
And we broke down the mechanics of the outsider anxiety. We look at the structural shift in the value of cognitive labor, how historical biases are baked into vector embeddings, and why the black box creates an incredibly rational lack of trust.
We saw how that collision creates chaos in capital markets and triggers a dangerous pendulum swing in policy, oscillating between reckless deregulation and clumsy hardware restrictions.
Yeah.
And finally, we looked at the structural requirements to fix it, demanding transparency at the perimeter, funding interpretability, and treating socioeconomic stability as a core engineering metric. You, listening right now, are a crucial part of this dialogue, because you are now armed with the underlying mechanics of this debate. When you see the massive market shifts or the new legislative proposals, you aren't just reacting to the surface noise. You understand the structural forces driving the collision. You are actively participating in shaping this marathon.
This raises an important question, though, and it's a final thought I'd love to leave you with.
Let's hear it.
As you watch this field evolve, this paradox we just landed on is the most critical dynamic to monitor. If the primary solution to public anxiety is education and transparency, but the frontier models are becoming so mathematically dense that their own creators cannot fully explain how they reach certain conclusions, How do we successfully educate a divided public on a black box that has outgrained human comprehension?
That is the ultimate engineering challenge of our time, and it's a question we all need to be asking as the marathon continues. Thank you so much for joining us on this deep dive. Keep questioning, stay incredibly curious, and keep engaging with the conversation. We'll see you next time.